following program is a presentation of Grace Chapel, Tullahoma. Grace Chapel is a non-denominational church focused on the Christian fellowship of believers in an environment committed to teaching the entire counsel of God. Grace Chapel teaches verse by verse through the Bible on Sunday mornings at 9:45 a.m. and on Wednesday nights at 6:30 p.m. For more information on Grace Chapel, feel free to visit our website, www.gracechapeltullahoma.com, or call 931-581-3294.
What about the 1800s? Well, it just continued. Science was still dominated by privileged thinkers, men of wealth and ease who had the time to spend on this kind of stuff and weren't accountable to anybody. Scientists began to call for a plausible, non-religious theory of origins. They finally wanted something they could seize on that would prevent or would preclude the need to be a creationalist. Any reasonable theory in this age gained an audience. Edward Blyth, he was a zoologist who wrote numerous papers on processes for organism adaptation. He believed that evolution could change an animal, but he didn't believe that you could actually create new species through this process. He was not a pure evolutionist. In fact, he was a Christian by some accounts. His theories were heavily borrowed by Darwin. Darwin is the one who attached the name natural selection to them. Then you had Alfred Russel Wallace. He developed a theory of evolution by natural selection as well. He published some of those ideas in 1855. He made the mistake, though, of sending a copy to Darwin in advance, which gave Darwin something he could use, and Darwin is actually credited with the theories that this man originated. Friends of Darwin arranged to have Wallace's paper read at the Linnean Society of London as if it was Darwin's own work. It's sort of like whoever gets published first gets the credit. Well, this is how they were published in the day. Darwin's later books claimed ideas first developed by Wallace. Wallace began his career as a traveling naturalist, already believing in the transmutation of species. It was widely discussed but not generally accepted by leading naturalists and was considered to have been radical, even revolutionary. It had been suggested that Wallace accepted the idea of transmutation of species in part because he was inclined to favor radical ideas in politics, religion, and science, and because he was unusually open to marginal, even fringe ideas in science. He was the first guy to widely call for the belief that one animal could change into another, transmutation of species. No one else to that point had gone so far in their belief of evolution. He was the first. Why was he the first? Well, as you can see, because he loved wild speculative ideas and he was on the fringe. He was a radical. Not because he was a good scientist, because he happened to believe things in a radical way. Then there's Charles Lyell. He is the first to attempt to prove what James Hutton suggested, which is that the earth is very old. He developed theories for sedimentary strata, this idea that we've seen already that said that the earth and the layers of the earth that Hutton said were evidence of ages of time. He tried to investigate that theory and tried to prove it. He wrote something called the Principles of Geology. He is considered the father of modern geology. Virtually all the major tenets of geology started with him, and particularly with this book. One of his statements, or one of the statements about him, he was the major advocate of James Hutton's idea of uniformitarianism and that the earth was shaped entirely by slow-moving forces that are still in operation today, acting over a very long period of time. That's in contrast to catastrophism, which is what the Bible would argue for if you want to put a scientific word to it. That is that there have been these moments of abrupt change, like the flood, or like the creation itself, which have been adapted in England to support the belief in Noah's flood. So Lyell saw himself as the spiritual savior of geology, freeing science from the old dispensation of Moses. Moses is a reference to the 5 books that he wrote, to Genesis. So is this man conducting science, or is he on a religious war? Well, his motivation was to free us from this shackle, this chain of the Bible. Let's move on from that. Is it religion versus science? Or is two forms of religion? One of his most famous experiments, I want to show you how their motivation compromised their objectivity and their willingness to conduct science in a true and honest way. Here's an example of that. He went to Niagara Falls. You've seen these pictures. Maybe some of you have been there. You can see the horseshoe falls here where the water is coming over the rock at such a tremendous rate that it's constantly eroding the edge of that falls. And you can see, just by looking at the screen of this picture, you can see that while the falls are right here, at some earlier point they were right here, and at some earlier point they were right here. The water is eroding this channel as it falls over the edge. It's eroding it at a very fast rate, and a rate that's very easy to measure. Well, Lyell thought, well, if I go to this place and measure the erosion rate, I can then calculate how fast that's happening and go back in time to where this channel begins, and I'd be able to see how long has this been going on. So he observed that the walls are made of limestone and shale. That's very soft, relatively speaking. And he thought that this erosion would be like a clock that measured how long the earth has been in place. The gorge today, from where the falls are today to where we can see that they started at some earlier point in history, is about 35,000 feet. Well, do the math, right? 5,280 feet in a mile. That's roughly 6.5 miles. You got 6.5 miles of gorge. Well, now he just had to know how fast is it eroding and then do the math. Well, the residents of the area could report to him with fair precision that they were watching the erosion of about 3 feet a year in the movement of the Horseshoe Falls. The problem with that number is if you do the math, it's not long enough, so he changed what they told him. And that gave him the chance to say it's 1 foot a year, 35,000 feet, 35,000 years. Ha-ha, the earth is old. At least older than the Bible maintains. But if I do the math properly, what do I end up with? Not 35,000, but about 7,000 to 9,000. And keep in mind, that's assuming there's never been any change in the history of the earth. If there was ever some time in the past, for example, when maybe a large quantity of water was flowing on the earth, maybe a huge quantity of water, then the erosion rate would be faster during that time, right? In which case my math wouldn't work out very well. There's a simple example of uniformitarianism that I can use to explain this concept better. If I brought you into this room and there was a candle standing here, a long candle burning, and I asked you, how tall was this candle when I first lit it? What information would you need in order to know how tall that candle was originally? You'd need at least 2 pieces of information. You'd have to know how long it had been burning and what else? And the rate of burn, the rate at which it's consuming the wax. So if I told you the rate is a certain amount per hour and then I give you it's been burning for 5 hours, you can do the math and you can say, well, it used to be this tall, right? Well, that's what he's basically doing here. Uniformitarianism only works, though, if I assume nothing changed in the past. What if I told you that for part of that time I had a fan blowing on the wick, causing that candle to burn faster and to consume more wax, and I had the fan on it for 30 minutes within that past history of time? Well, now your math won't work anymore because the rate changed during that time. Well, uniformitarianism is so essential to evolution because if you don't assume uniformitarianism, you can't do any math. But the problem with that assumption is we know from Scripture that the world hasn't always been the way it is, and in fact it's gone through dramatic change. If we believe that to be true, then we would also have to believe that uniformitarianism is not a safe assumption anymore. They obviously don't hold to the Bible, and so they are working with that assumption, and here's the kind of problems you get. Never mind the fact that Lyell was dishonest in his work, because his desire was what? To free us from the shackle of Moses, not to uncover the truth. There's a difference. Now, I'm not saying that because he did something wrong, every man does, but you've seen already the rogues gallery of history. These are not men who are working from a scientific perspective. They're working from other perspectives, speculation, religion, etc. Now, in the same time frame as all of this is going on, you have men like Louis Pasteur, who was a good man of science and did some very valuable work. He wanted to discredit the theory of spontaneous generation. Remember, we mentioned that a moment ago in one of the earlier slides. We have a man who is proposing this as a way of explaining origins. Spontaneous generation, you know what that is? Spontaneous generation says, and this was a view that many scientists held to, by the way, it says that life arose from non-life spontaneously. So you have some trash sitting somewhere in the corner of your house. You go to pick up the trash, maybe a pile of dirty clothes or maybe some rotten garbage. And as you pick it up, out run rats. Oh, well, where did these rats come from? Well, they must have spontaneously came from the garbage. That's what the theory proposed. That organisms that appear have come from something that was previously inanimate. And they made that association because in life they could observe in meat, for example, maggots, or in trash, rodents or insects. Where did these things come from? Well, they must have come from the object they're in. That must be spontaneous generation of life. Louis Pasteur said, that doesn't sound right. That doesn't sound like science. There's something wrong with that. I can prove that that's wrong. And he conducted a very famous experiment. You may know this experiment, in which he took a broth mixture and boiled it in a flask, and then sanitized it by the boiling, killed all the organisms in it, and sealed the flask, and left it sitting that way for an extended period of time, and waited to see if anything would grow in that flask. And of course, since it had been sterilized and covered, nothing ever grew in it. It stayed pristine. And then he took the top of this flask off and let it expose to the open air, and within a very short period of time, there was bacteria and mold and other things growing in it. This is something every kitchen cook has seen and knows exactly well. What we now understand is happening is that there are biological organisms too small to see in the air, and as they collect on something and grow, they can become large, and a quantity can increase to the point where we can see it. But in that day, they viewed that as spontaneous generation. By his experiment, he proved that nothing would generate inside of a place that was sterile. There was no spontaneous generation. It was in the air already. And so he disproved spontaneous generation. That left the scientific community without any theory for the origin of life. That was the best they had, which is pretty sad. Throughout history, we have entertained two kinds of views of the origin of life. One, that life was created supernaturally. The other, that it rose spontaneously from non-living material. For almost a century afterward, biologists proudly taught their students this history in the firm conclusion that spontaneous generation has been scientifically refuted and could not possibly occur. Does this mean that they accepted the alternative view of supernatural creation? Well, not at all. They just had no theory of the origin of life. And if they were pressed, they were likely to explain that questions involving such unique events as origins and endings have no place in science. In this case, it would seem that science has vacillated not between two theories, but between one theory and no theory. You see the religious aspect of this showing up? If science was pure and true in its pursuit of knowledge and of the truth, then we would adopt the second theory, at least until we had something we preferred. But because it involves faith, they reject it out of hand, like the scientists from KSU said, and they go with nothing in preference to that. But they meanwhile search for some other explanation. It is a faith-driven search, not a science-driven search. Lastly, A.F. Leopold Weismann, he considered one of the founders of genetics. He wanted to prove that Lamarck's theory of acquired characteristics, his theory of inheritance of acquired characteristics, was true. He wanted this to be true, so he went after it with a scientific process. Remember what it said? It said that if a giraffe tried to do something, it would change the body for the next generation. So he thought that if he took baby mice and he cut their tails, if he cut the parents' tails, then the babies of those parents, the new mice, would come out with shorter tails. So he took a bunch of mice and he started cutting their tails. 901 mice in successive generations. So he'd have a mouse, cut the tail, breed it. Take the babies, cut the tail, breed it. Take the babies, cut the tail, breed it. Sooner or later, what Lamarck predicted would have to be true, right? Sooner or later, you'd get shorter tails off that process if the theory was true. So he's cutting tails, making them unhappy. And of course, tail length never changed. Why? Because you're not changing the genetics in the animal. You're simply changing the features of their body, and it doesn't pass on through genetics. We know that now, right? Because we know how DNA works, but at the time they didn't. And then lastly, Charles Darwin. He was born into wealth. He lived a life of ease, as men of his day did when they had money. He dropped out of medical school. That was the only science training he ever received. He actually got a degree from the Church of England, ironically. He wrote Origin of the Species, of course, which was his most famous work. And from what he wrote, we have all that we know today, or that we credit to him today in the Origin of Species and natural selection and so on. What do we have, though, at the end of this age? At the end of the 19th century, what do we have? Few fossils existed. No one had dug anything up, and the few that had been found were not considered significant. No one was analyzing them for any scientific purpose. They were just dead animals in the ground. They didn't care. It didn't promote any part of the theory. It was just ignored. There was no knowledge of DNA. There was no rock dating methods. There is no empirical proof. We're still working merely based on speculation and observations and some dishonest work on top of it all. And yet, by this point in history, these things have already become part of science. These theories, these ideas are already driving science in the world. But none of those things had come with any proof or with any kind of support from what they had done in terms of science. They've just been adopted in faith. Isn't that amazing? Wouldn't it be interesting if math worked that way? We just start saying 2 + 3 is 4 because somebody said it's true and no one ever bothers to test it? That's what's happened in this area of science, in evolution. All right, there's really not much to say at this point. We know how the world has gone since that day. Science has embraced Darwin's ideas even before the support emerged. All theories have been reformed according to evolution, as we said earlier. All research results today are judged according to how well they support Darwin's theories. Do you want to do well in a field of science, maybe as a research scientist or a professor at a major university? Make sure that everything you do in your field of science lines up with what Darwin and all who have come from him tell you is true. Do you want to lose your tenure? Do you want to see yourself put out of work faster than you can imagine? Publish one, or try to publish one thing that suggests Darwin's theory is false. It'll be the end of your career. And if you think I'm exaggerating, I can give you some examples in the recent history of men who have found that to happen. Even men who are not Christian, who are not trying to propose creation, they're simply trying to do honest science, and they go into the literature and they say, this doesn't make sense, and they're ostracized immediately. No differently than if someone came in here and said to us that Jesus wasn't the Son of God. How long would we tolerate that teaching in this room? Hopefully very short time. Hopefully not at all. Because it's a religious view that we know is wrong, given our religious view out of Scripture. Well, it's a religion for them as well. And if you come in and deny the orthodoxy of their religion, you are ostracized immediately. There's no opportunity for rational conversation or for true science. So, thousands of fossil species have been found. DNA has been discovered in this century. Rock dating methods have appeared. New missing links have been proclaimed every few years in the literature. And those discoveries are now claims for crediting. Those are now the claims that they point to as proof of a theory that originated before all those things even existed. So we're going to look at the scientific evidence for evolution. If we're going to do this in the proper way, we have to work science in the scientifically sound manner. And that means following the scientific method. This is how all science is done today, or should be done today. You're taught this in basic grade school science, the idea that we have a process by which we discover truth in the natural world. The process is really very simple. Now, it can get very complicated depending on what you're doing, but the basics of it are pretty simple. People go into the world, the natural world, they make observations of what they find in the natural world. We've seen that already with some of the men we just talked about. They went out and they made observations. That's not wrong by itself. That part is perfectly natural. From those observations, we would propose to explain what we see. So in the way that James Hutton or Charles Lyell or any of those other men did, they went to the world, they looked at what they found, and they came away with a possible explanation for why it was, or for how it worked. From that, though, the scientific method then says, you now have the requirement, if you're going to do real science, to test your theory, to test your proposed explanation. A test must be constructed in such a way that it can reveal whether or not your theory is accurate, is true or not. That's what a good test would do. And of course, based on the results of that test, you would then have something to go back and re-observe, re-propose, rework your theory in some way. That's the scientific method. And you just continue on that path until you uncover the truth of what is. So let's go through that process at a very high level and see what we can do, or what has been done, to uncover the truth concerning the natural world and the truth concerning what evolution proposes. So first of all, can we observe anything in the world that supports the theory of evolution? What observations can we make in the natural world, or what observations have other people made? And to do that, to make this process a little more structured, let's use a standard definition of evolution. I gave you one earlier that was mine, but this is one that the Oxford Dictionary proposes. I assume you'll agree that's a fairly sound source, the Oxford Dictionary. The Oxford Dictionary says there are going to be gradual processes by which the present diversity of plant and animal life arose. That's the first part of the definition. So the definition of evolution is that you should go out into the world today and find gradual processes by which the present diversity of plant and animal life came about. So let's go see if we can observe that. What can we go observe? Well, plant and animal life arising from non-life. That's part of the theory. Well, let's go out and look for that. Can you go out in the world today and observe that happening? Inanimate things, bang, something happens, and you have real life. Can you observe that? Can you observe the creation of life from non-life? Rocks or other elements turning into something that's living? Actually, no, you can't. No one's ever done it. Ever. There's no evidence of it. It's never happened one time. In any time in history or any time in science, no one has ever observed that happening. Well, wait a minute. The theory says that's what happens. How do I test something I can't even observe? And then the theory says as well that there are transitions between life forms. Remember the definition from the Oxford Dictionary. It says that the diversity arose. Not just that life came about, but then it became diverse. Can I observe transitions between life forms? Can I find an example in the world in which one animal becomes another animal? No, I've never seen that. No one's ever seen that. Did you know that? Never, ever has anyone ever found an animal transitioning to another form. And we're not talking here about a black cat having a white cat baby. We're talking about a cat having a dog as a child, as an offspring, or even anything close. Or any animal having as its offspring something that is fundamentally different from itself. It's never been seen. Never. Ever. Well, wait a minute. These are foundational principles to the theory of evolution. This is the basic stuff that the theory says is happening all around us all the time. You mean in terms of a cocoon? It's the same creature, right? Though, I mean, in other words, that creature is programmed from its beginnings to move in that form, to change in that form. But that is the same creature from front to back, right? We're not. What is the baby of a butterfly? A cocoon. Right? I mean, the process just keeps going, right? It doesn't move on to something new and different. So, in keeping with what God said, things are producing after their own kind. New kinds are not emerging from existing kinds. But that's a basic element or basic tenet of the theory of evolution. You would think, folks, that if this is so pervasive and so dominant, it's the thing that explains everything in existence, you would think that somewhere in the recent past, somebody might have come upon it happening somewhere in the natural world. How does it happen all the time, everywhere, and yet you can't ever see it? That's a fundamental barrier to science in this particular arena. So if I can't observe the origin of life or even the transmutation of species, can I at least find evidence that the genetic code of animals, which we know is the thing that controls the reproduction process, it's the thing that programs our offspring, can we even at least find at the DNA level the origin of new DNA? Because that's how it would have to work, right? If a cat, so to speak, is going to give birth to a dog, somehow the DNA in that cat would have to change to the DNA of a dog, or anything else for that matter, right? Can we at least see that happening, maybe at a molecular level? Is the DNA ever changing? No, we've never observed that. Did you know that? We'll talk more about DNA and the structure of DNA and how we see that structure changing. But just so you know, right now, there has never been a documented case ever of DNA mutating in a way that produces a new species, or anything even close to that. So I have a theory that says there's a gradual process by which the present diversity of plant and animal life arose, and yet I have absolutely nothing in the natural world that's ever been observed by anyone that shows any of that happening. That's why we call it a theory. Although, as you saw, many want you to say it's a proven fact. It's kind of hard to prove something you haven't even found. Now, if you think I'm overstating it, that's a healthy perspective. That's not unhealthy. That's a healthy perspective. You should doubt things you're told. You should have a critical mind. Go research it. The world of data is out there waiting for you. Go research it and see what you find. And I'm very confident, in fact, I'm 100% confident this is what you will find. So if I'm supposed to observe basic elements of the theory, but I can't, then I'm left without the possibility of even beginning the scientific method, of conducting true science in the area of evolution. So if Darwin didn't observe evolution, because we just said it can't be observed, it's never been observed. What did he observe? Because we know he saw something. He wrote about it. And other men like him did that as well. What did they observe? Well, most famously, and this is not the only thing, this is not the only thing he did, but most famously, he's known for the voyage of the Beagle. The Beagle is the name of this ship. It circumnavigated the globe over a series of years. Darwin was a naturalist. And a naturalist sounds like a really cool term, doesn't it? Especially in these days, everybody's very nature-oriented and green and everything else, right? But in that day, it had a different meaning. Naturalist was the name you gave to a rich playboy who had nothing else productive to do with his time, so he became a naturalist. And I'm not overstating it. That's literally what these people were. They came up with this name because you weren't a scientist, you didn't have a degree of any note, you didn't have a job, you didn't have any way to be productive in society, so you traveled around the world observing things. We call them tourists today. They called them naturalists then. But he did try to approach his work with some rigor. He kept a very detailed notebook, a diary of what he observed. He did get very interested in certain things he saw, and in particular, in one place more than any other, on the Galapagos Islands, he noticed some things that caught his attention and led to writing the book we now credit to him, The Origin of the Species. So Darwin wasn't, I'm kind of overstating it, he wasn't just along for a joyride. He was doing things he felt were productive. My point, though, is it's not science in the traditional sense. It was something less than that. When he got to the Galapagos Islands, what he noticed was that they have a unique collection of animals, a unique collection of indigenous animals that were different than animals he found anywhere else he had been. They're in some ways like Australia. They have animals that you won't find anywhere else on the planet. As one example, he found finches that looked very different than the kind of finches you would have found on the mainland of South America. Or of Africa, sorry. If you look at this is a good collection of finches that you can find in different places. And on the Galapagos Islands, there were finches that were unlike any other. Now, what was different about them? Well, primarily the beaks were different. The finches on the Galapagos Islands had very long, narrow beaks, where the average finch, as you can see in these photos, has a very squat, flat beak, very short, very wide. And he was curious as to why these particular finches had such a different beak than any he had seen anywhere else. What he noticed was that the Galapagos Islands are volcanic. And so the ground is volcanic. You ever seen a volcanic rock? That black rock full of holes? Well, the seeds that finches traditionally feed upon are very small seeds. And if you throw a bunch of small seeds onto volcanic rock, what happens with those seeds? They fall into the holes. If you got a fat, squat beak, you're not eating very many of those seeds. But if you happen to have a long, thin beak, you're in pretty good shape. You'll get more seeds. And what Darwin began to understand as he watched this play out and saw this in the natural world of the Galapagos Islands, he began to realize that these birds had adapted from the birds on the mainland to have longer beaks than their brethren did on the mainland so that they could survive under these circumstances. And it caught his attention and led him to start forming this theory, borrowing ideas from other men along the way, and come up with the idea of natural selection. So that's one of the things he observed. He observed finches with different sized beaks. He also observed other animals as well. But as you mentioned, as we can all see for ourselves, they're all still finches. He didn't observe a finch turning into something else. He just noticed that they had evolved in a way that changed their features compared to the other finches of the world. So if men can't observe the forces of evolution at work, how do they test that theory? Well, let's look at the test idea for a moment. And I just highlighted one of Darwin's observations. Obviously, there are many others, but they all run along those same lines. And we'll come back to explaining what happened with those finches later. But just so you know, that's the kind of observations you make, that animals can adapt, that things change, there's things changing because of environmental forces, and so those observations led to the theory we now have. But they didn't observe what the theory proposes, they observed other things which they then assumed could allow for the things that the theory proposes. That if this kind of a thing could happen to a finch, then maybe it would be strong enough of an effect that if given enough time, finches could turn into something else. That's the way they extrapolated from what they observed. So the fundamental tenets of the theory are just simply untestable. You can't test the origin of life if you can't find it happening. You can't test transmutation of species if you don't find it happening. There's nowhere to start. You can't test a theory for evolving of life by examining dead things. I can't go to fossils and learn anything about how living things evolve. All I can study is what that animal was when it died. That doesn't get me to the answers I need when we're talking about how things evolve. And then there is this problem of time again. Evolution says that this is a gradual process. Remember the definition? It said gradual. And when they mean gradual, when they say gradual, they mean gradual. They mean millions and millions of years. Well, if the theory says this only happens with millions of years, how do you test that? Unless you plan to live for millions of years, you won't be around long enough to test that idea. So the very nature of the theory is untestable. And if it's untestable, it's unprovable. If it's unprovable, it can never lose the title theory and become fact. It's an idea. That's all it is. So it's unprovable, untestable, so all we're left with is explanations, proposed explanations, ideas, thought. So, let me back up for a second. So, if we can't use the scientific method, if it's literally impossible to prove evolution by the standards of science, then what kind of proof can we use? What has allowed the world to feel so confident about something that they cannot prove scientifically? Because obviously they believe it strongly. Every scientist in every major field today would tell you that it's true. How did they get there if it's not provable? Well, there are things they would cite or they would point to you and I as proof. Let's look at some of those things. They would point to things like the age of the earth. They would point to evidence found in the geologic column. That's a term for the layers of earth you see when you look at the side of a cavern or a cliff, for example. They would point to the fossils that they find in those layers. They would point to the idea of natural selection, and they would point to anthropology, the study of human ancestors, so to speak. So let's go through these. This is where the science of evolution starts to really come to bear, or the so-called science of evolution. Let's start by understanding the age of the earth. Let's go back to our definition for a minute. You notice in our definition, it's a gradual process continuing for the past 3 billion years. That's part of the definition that Oxford uses for evolution. So we have a gradual process that took 3 billion years to get to where it is. So clearly, evolution needs time. It's essential. Lots of time. And it moves so slowly, you can't see it. And you can compare it to the hour hand on a clock, especially when someone like me is talking. It just seems to move so slowly. The hour hand, you can see the second hand moving, and if you stare hard enough, you can kind of see the minute hand moving. But I don't care how hard you stare, you can't see the hour hand moving, right? You only know it's moved when you come back a little later, and it's moved from where it was before. That's how evolutionists ask us to conceive of the process of evolution. It's happening. Trust us, it's happening. It's just happening so slowly, you can't see it. But it's there. And if we could be here for millions of years or billions of years, you'd see it. Trust us. That's effectively how the theory deals with the issue of time and with the fact that we can never observe it in the natural world. They would tell you it's like the hour hand. It's happening, we just can't see it because it's a long period of time. So it's essential to the theory of evolution that we find some evidence in the natural world that the earth really is that old. It becomes essential. If it were true that the earth wasn't that old, the whole theory goes away in a heartbeat because it depends on time. So there's ways in which they propose that you can measure or detect the age of the earth. Because if you think about it, that's a pretty hard thing to do. How do you measure time in terms of the presence of something? How do I know how long the earth has been here? How do I figure that out? Well, they propose things like interstellar distances, using the fact that the universe is constantly moving and moving away from its center, and maybe that's a way of measuring time. Sort of like the candle example. If I can go back in time, I can see how long has this movement been taking place. Or ice layers in parts of the earth where it's very cold, ice is deposited every year. Again, using the theory of uniformitarianism, they can make assumptions about how long has this been going on. Or radioisotopic dating, that's the rock dating that you hear so much about. They propose we can date rocks or date other elements in the earth. And then finally, the geologic column. We'll come back to that one a little later. So let's start with interstellar distances. These are photos from the Hubble telescope. They're really pretty, the amazing beauty of God's creation. And if we go into the interstellar realm, into the span of the galaxies and the universe as a whole, we can begin to look at ways to measure there and try to discern how long things have been around. Because in terms of space, distance is a measure of time. Distance is a measure of time. For example, we know that light travels at a certain fixed speed, 186,000 miles per second. So if I know there's a fixed limit to the speed of light, to the traveling of light, and I can see that an object is a certain distance away, and I know the light from that object is reaching the Earth today, then I must assume that it's taken the time that required for light to travel, it's taken at least that long for time to pass. So if I have an object that is 5 light years away, and I'm seeing light, it's taken at least 5 years for the light to get to me, ergo we've been around at least 5 years. And there are objects in the spans of the heavens that are so far away that it would have taken 1,000,000 years for the light to get to us, or 1,000,000,000 years for the light to get to us. And so, by that same logic, the scientists would conclude that we've been around at least 1,000,000 years, or we've been around at least 1,000,000,000 years, because otherwise we wouldn't be seeing the light from that object. How do we answer that? Is that truly proof that the universe is that old? Well, if you were here for the study we did on Genesis, and particularly last night when we looked at the sun and the moon and the stars, what did we say God has the power to do as he creates the universe? Right. He not only created the object, but he created the light beams that connect us to the object from day one so that they could be seen, because that was his purpose in creating them. He didn't need to wait billions of years for the light to get to us. He just put a beam of light on a path between us and the object from the moment it was created, and then forevermore after that, the light has continued to stream toward us. But it's a contrived expectation that we say God must have waited 1,000,000,000 years. There's no requirement that he do that. If he had the power to create the object, well, he certainly had the power as well to create the light beam between us. And he did so for good reason. So from a creation's point of view, it's not proof of anything, but of course, if you are a secular scientist who does not believe in the Bible, that answer is not going to satisfy you, is it? But the point to the Christian is there is an answer, a very sound answer, one that's consistent with Scripture, by the way, to explain why we can see such things from such a far distance away. It doesn't negate Scripture, it's very compatible with Scripture. What about ice layers? Greenland, Iceland, places, particularly Greenland, you know, they reverse the names, right? Greenland's the cold place, Iceland's the nice place, relatively speaking. Greenland has a tremendous amount of land covered by ice and deposits of ice, and every year a little more comes on top of what was there the year before. So more falls, and what was already there doesn't melt. Not this year, maybe, yeah. Scientists speculate, and I'm using that word purposely, scientists speculate that one layer is equal to 50,000 years. Now you're going to ask me, I hope, the obvious question. How did they get to that? And I already gave you the answer. They speculated. There's no way to know that. There isn't any way to know that, right? No one's been around 50,000 years. There's no way to know that. So they, and by the way, that's such a perfectly round number, isn't it? And so they said that if there is so much ice on the ground and I have 50,000 years per layer, when they dig core samples through the ice and they come back with 500 layers, they just do the math. And they say 500 times 50,000, that's how old the Earth is, or whatever the number was. But it's all hinging on that first assumption, right? What if it's a lot less than 50,000 years? Well, you all heard the story of the Lost Squadron. In I think it's 1944, they crash landed in Greenland. 42, sorry, that's right. 1942, they crash landed in Greenland. This is a squadron of P-38s that were lost, ran out of fuel, had to ditch. They literally landed on the ice in Greenland. At that point, there was no way to get them refueled and get them back in the air, so they had to be abandoned on the ice. And so they were rescued. The men were rescued, but they left their planes behind. Now, in today's world, those planes would be very valuable because there's very few of them left, and so these are relics that would carry a great deal of value as a historical relic, right? So, in 1988, they went back to find them, and they finally discovered them under 250 feet of ice, and that ice had flowed in the course of time, so that now they were 3 miles away from the landing site, buried in 250 feet of ice. And you know they actually got down to the aircraft? Using hot water jets, they dug 250 feet down into the ice and uncovered. They have great, if you go online and Google this, they have great pictures of what they found under the ice, these perfectly preserved, almost perfectly preserved, airframes underneath the ice. But they are under 250 feet of ice. Well, according to the theory, The entire 3,000 meter Greenland ice floe, that's how deep the ice is on Greenland. 3,000 meters, that's 9,000 feet more or less, 10,000 feet more or less. They claim, the world claims, that those layers equate to millions of years of time. But if you do the math based on 250 feet in just 40 years, you end up with a max age of Greenland's ice floe of only 2,000 years. In other words, what the world has assumed about the speed of that deposition is far longer than in actual fact what we now can verify is happening. Because of the squadron, we now can see a definitive beginning and end time, and we can see that in just 40 years, you get 250 feet of ice. And the entire Greenland ice floe is only 3,000 meters, comparatively. You can get that in just 2,000 years at that rate. That's a far shorter time than anyone would ever have thought was true. It completely disrupted their theories concerning ice flows. In fact, now they've had to rework their theories, and they have concluded that it is a matter of the ice age cycle, not of some absolute measure of time, and so they no longer use it as a measure of how old the Earth is. It's amazing how facts get in the way of the theory, isn't it? What about rock dating? Now, this one you hear about all the time, right? Very, very hard to get around this one, right? This is the linchpin in the theory. We know the Earth is billions of years. They keep dating rocks every time we turn around. We know that's what they keep telling us, right? Well, there's multiple forms of dating. There's carbon dating, there's uranium-lead dating, and there's potassium-argon dating. They all work on a similar principle, but they are significantly different, and there's reasons why we should care about the difference. There are other methods that are being developed all the time, but again, they all work on a similar principle. Let's look at carbon dating, and you can learn the principle from learning about this one example. Carbon is a basic element of living creatures, of life. And in the atmosphere, in the air that we're breathing, the atmosphere that surrounds the Earth, there is a stable isotope of nitrogen called nitrogen-14. It's an isotope, but it is stable in the atmosphere. That isotope, though, becomes a radioactive isotope of carbon, carbon-14, when sunlight strikes the Earth's upper atmosphere. So the nitrogen-14 that's already in the atmosphere, floating around the Earth with all the other stuff in the air, when it's exposed to sunlight in the upper reaches of the atmosphere, the energy of the sunlight changes the molecular structure, the atomic structure, and creates carbon-14, a radioactive isotope that is not stable. It decays. Over time, it reverts back to nitrogen-14. So it began as nitrogen-14. Sunlight turns it into carbon-14, but that's not stable. It wants to go back to where it was, and at a predictable rate, at about 5,000, a little over 5,000 years, every 5,000 years, every 5,200 years or so, half of that carbon-14 will have gone back to nitrogen-14. That's the half-life of that radioactive isotope. Now, plants in the world that we live in, plants, what do they absorb through their leaves? They absorb carbon dioxide. They breathe carbon dioxide in, they give off oxygen, right? Well, this carbon-14 that's being created in our upper atmosphere, it's floating through the entire atmosphere. Right now, as we sit here, we're breathing in carbon-14, along with nitrogen-14 and other things as well, right? Well, so are the plants. The plants are taking in carbon-14 in the form of carbon dioxide with some carbon-14 molecules or carbon-14 atoms in that molecule. They absorb carbon-14 in an amount equal to the amount in the atmosphere. Another way to say it is, if I put you in a pool that has chlorine in it, and I put a certain concentration of chlorine in the water, what concentration of chlorine comes in contact to your body when you're in the water? Whatever's in the water, right? Whatever level's in the water is what you get on your body. In a similar sense, a plant is surrounded by an ocean of air, and whatever concentration there is of carbon-14 in the atmosphere, that's how much it's taking in as it breathes in carbon dioxide. When that plant dies, the carbon-14 that's in the plant at the moment it dies is fixed. It stops taking it in because it's dead. But carbon-14 begins to decay at that point. And if that plant is fossilized and preserved in the ground, after 5,200 years or so, that plant fossil will have exactly half as much carbon as it had, carbon-14, as it had the day it died. Because it decays at such a predictable rate, I can make an assumption about how long ago it died if I compare the amount of carbon-14 in it to the amount of carbon-14 in the atmosphere. Remember, when it died, it had the same amount as the atmosphere. but then at the point it died, it started losing it at a predictable rate. If I compare it to the atmosphere, I can see how long ago did it die, by how much has been taken away by the radioactive decay. Everybody understand that? It's a little science there, I know, but you get the point. That's how radioactive dating works, or carbon-14 dating works. So carbon-14 is a measure, carbon dating is a way of measuring how much carbon-14 is still left in a plant, and then we can say how long ago it died. Now, what about animals? Well, animals eat plants. So the carbon-14 that they eat was the carbon-14 that was in the ground or in the plants in the day they ate it. So you and I and animals and plants, we all have in our bodies the same amount of carbon-14 as is in the atmosphere around us because we absorb it at the same rate. It's kind of like the chlorine example. You have in you whatever is in the world around you.
You have to assume the same amount of carbon.
Bingo. Bingo. What do you have to assume? Well, number one, you can only measure living things with this. Did you know that? You cannot do carbon-14 dating on a rock. It has to be something that lived at some point in the past. So carbon-14 is only usable as a method for dating things that used to be alive. Second thing, you can only date to about 40,000 years old because after 40,000 years, there is so little carbon-14 left, it's undetectable at that point. So there's an upper limit on how old something can be and still be a good candidate for carbon-14 dating. If it was alive longer than 40,000 years ago, can't use carbon-14 anymore. And then, as you said, it assumes a constant level of carbon-14 over time, and yet what we actually see happening in the world today is the level of carbon-14 in the atmosphere is not stable. It keeps rising. There is more today than there was yesterday. There's more today than there was 100 years ago. It seems to still be rising. We've never reached a static or stable level in the atmosphere. So there's no reason whatsoever to assume that the stable level, the level we have today is what a plant had 1,000 years ago or 5,000 years ago. In fact, we have opposite evidence. It's been increasing. Remember my example of the candle? If anything of the past is not the way it is today, you can't make any guess as to how long it's been around. Because without uniformitarianism, the math stops working. We use carbon-14 dating to date things that used to be alive, but we assume carbon-14 levels are unchanging, and yet we can see today that they are changing, which makes this method completely useless. In fact, in real-life practice, you get wide variations in dates. I can measure two fossils taken from the same place in the ground of the same plant and get different dates. Well, of course I do, because it's not an exact process. It doesn't work because the math is wrong. In fact, because it's so wrong, it's almost never used today. The scientific world has all but abandoned carbon-14 dating. It's almost never used anymore. When's the last time you heard of anyone doing it? Well, you probably don't look for it. But if you look in the literature, it's disappeared basically from the literature. It's considered because of two things. It doesn't go back far enough, and it's unreliable. And yet, people will throw that term out like, oh yeah, we carbon date stuff all the time. No, we don't. And when we do, we get bad data. Another method that now has been preferred in some respects is either uranium, lead, or potassium argon dating. These have a similar idea, something that started in a certain form and then decays over time. In the case of these methods, we're talking about basic elements that decay into another. Uranium eventually becomes lead if you wait long enough, as well as potassium becoming argon. So what we do is we take a piece of rock and we measure in that rock how much of the daughter atom and the parent atom exists. How much uranium, how much lead, how much potassium, how much argon. And then we look at the ratio, and then we say, based on that ratio, we will find out how long this rock has existed. Now, what assumptions am I making there? Well, I'm assuming that when the rock was originally formed, it was all parent atoms and no daughter atoms at all. And whatever daughter atoms are there today are there as a result of the radioactive decaying process. Well, why would I have that assumption? We see evidence in the world today of rocks that come into being out of volcanic flows that have all kinds of atoms in them, that have a variety of these atoms from the start. In other words, it's not a safe assumption that all lead, it was all uranium and no lead, and now there's some lead because there's been some decay and therefore it's millions of years old. It's a completely bankrupt assumption. Furthermore, it can only be used on igneous rock. Now what is that? It's rock that's formed in a volcano. It's that red flowing lava stuff that you know is burning hot. When it cools, it forms rock. That's igneous rock. Guess what? You can't have a fossil in igneous rock. So there are three important assumptions here. No daughter atoms present, there's a constant decay rate, and there's no new source for the atoms. Those are all risky assumptions. And because it can't be used on sedimentary rock, it can only be used on igneous rock, you can't use it to date fossils. Let me explain that for a minute. Igneous rock comes out of a volcano. Sedimentary rock is like limestone. It's rock that began as mud, which when you really break it down, what's mud? It's little granules of sand mixed with water. Well, if I took one of those little granules of sand and I looked at it, what would it be? It's a tiny little piece of igneous rock. And if I take lots of little pieces of igneous rock and I move them all together and I put water in there and a little bit of dirt, I end up, and then I let it sit and form, it becomes sedimentary rock. Why can't I date sedimentary rock? Because it's mixtures of rock. It's not a solid single piece. It's a mixtures of lots of little pieces. It's like saying, how old is this church? The only way I can do it is by taking an average of everybody's age, right? There's not one single age for this church. It's a collection of individual people. Sedimentary rock is a collection of little tiny pieces of igneous rock. There's no single date for that piece of rock. The only way to date it is to know what day did the flood happen to create that rock. But the rock itself can't tell me that. Here's the trick. Fossils don't exist in the igneous rock that we can date. Fossils only exist in the sedimentary rock that we can't date. Because an animal doesn't stay intact inside a flowing lava rock. It only gets captivated or captured by sedimentary flows, which you can't date by these methods. So when you try to date these methods, you frequently get some very wild dates. Let me just give you an example. They did potassium-argon dating on a lava flow in Kenya. Remember, this is igneous rock, so we should be able to date it. Their theory was that this volcano had been flowing for millions of years, and we wanted to see evidence of that by dating the rock that came out of the volcano. So they took samples. They said the lava was 230 million years old after they did their dating, but then later they came into a digging area. They did an excavation in an area, and they came upon a human skull, which they said was 2.9 million years old. The problem was it was underneath the lava flow. How do you have a skull underneath the lava flow that is 209 million years old if the lava flow is 230 million years old? And then when they took more samples of the lava to try to understand why it could be that there's a skull underneath it, they ended up with this range of dates. They started with 230, and somehow magically they got down to the point where that was compatible with the finding of a human skull. What you're seeing evidence of there is that if you do the dating enough, you get wildly different dates. So when you get wildly different dates, which one do you use? The one that's most convenient to your theory. This is how it really works in science. This is a very well-known case study. You can go look it up for yourself. The KBS Tuft lava flow in Kenya. It makes sense in a way that this is what happens when you consider the origins of the theory. The origins of the theory were not rooted in science, they were rooted in speculation. So when I try to do something that approximates science and I get these wildly different dates, well, there's no surprise because nothing has been rooted in truth. It's all made up. It's all speculation. And even the methods they're using now to validate it are methods that are not inherently accurate themselves. And when you get different dates, you pick the one you like. If you were to pick the other one, by the way, you lose your tenureship, you're kicked out of your field of science, and you're ostracized by your peers. Or you can pick the date that works, and you get your recognition, and you published, and you continue to keep your chair at the university. Which one are you going to do? Upper layers, by the way, can often date older than lower layers. So if you're looking at layers of igneous rock and you take a sample from the top and a sample from the bottom, which one should be older? Well, according to the theory of evolution, the bottom should be older than the top. And often it's the other way around. How do they explain that? Well, the theory of the day is that natural geologic forces have come along at some point in the past to cause the strata of the earth to flip, like an earthquake, maybe. Sounds sensible at first until you consider that some of these regions in which you see the lower parts dating younger than the upper parts, some of these regions are the size of the state of Wyoming. We don't know of any natural force capable of flipping an area of the Earth's crust the size of the state of Wyoming. And that's what they are proposing must have happened to explain how these dates don't fit. Does that take more faith than ours? At least as much. So how do they correct for these bad dates? Well, they dismiss them if they don't fit the evolutionary timeline. That's a quote that's directly out of Nature magazine. And that leads us to dirty secret concerning radioisotopic dating, something you won't hear very often. Dating is usually never done at all. I mean, think about it practically. You're an archaeologist or you're a geologist, and you're out in the field, you've got your tent, you've got your four-wheel drive, you've got your backpack full of tools, you've got some laptop and equipment, and you're standing out all day, every day in the sun, cutting away at the strata of the earth, collecting rock samples, and you come across a rock sample. You don't have radioisotopic dating equipment right there next to you. And in fact, that equipment's very expensive. And it's very hard to gain access to it. And it's time-consuming to do the dating. And after all, we've been doing this long enough to know how old things are. We don't have to go back and date everything anymore. It's been found in the Cretaceous layer. It's been found in the Cambrian layer. We know how old that layer is on Earth. It's 500 million years. That's 200 million years or whatever. I found the rock in that spectrum, in that strata, so we can just say it's 500 million years old. It's much faster. It's cheaper. And it's redundant to keep dating everything. So we don't date things anymore. When they tell you that they found a fossil and that fossil is 500 million years old or 200 million years old, they did not go date anything. What they did was say, based on where we found it, that's how old we say it is. No one dates rocks anymore. No one dates anything anymore because it's so unreliable, it's so expensive, and they don't bother with it anymore. That's actually the truth of how they do things now, and you can verify that as well your own. The geologic column is used instead to date things.
Grace Chapel is a non-denominational church focused on the Christian fellowship of believers in an environment committed to teaching the entire counsel of God. Grace Chapel teaches verse by verse through the Bible on Sunday mornings at 9:45 a.m. and on Wednesday nights at 6:30 p.m. For more information on Grace Chapel, feel free to visit our website, www.gracechapeltullahoma.com, or call 931-581-3294.